Here is an example on transmission parameter. Find the transmission parameters for the two-port network in the diagram below. That is, find A, B, C, D parameters of the two-port network in this T network. Let's go to the subsequent slide to get the solution. To calculate A and C in the two-port network given in slide 22, we will place a voltage source at the input side of the two-port network, and then we'll place our high 2, that is open circuit, at the output side of the two-port network as shown in the diagram in this slide. When that is done, we will see that our high 2, remember our high 2 will be 0, so our high 2 is 0. The fact that our high 2 is 0 does not mean our 3i is 0. Please take note, because our 3i is a current control voltage source. So it's a source. It's not a resistor. It's not an element. It's not a resistor or capacitor or inductor. So it will not be equals to 0. 3i still remains. So we have, using Ohm's law, our V equals to I, that's Ohm's law, but our V1 here will be equals to the current flowing in the circuit, which is I1, that is flowing, multiplied by the equivalent resistors in the circuit. Now, the equivalent resistors in the circuit is the 10 plus 20. They will be in series. The two resistors will be in series and not in parallel if the high one is the one flowing through it. So it will be in series. So we have V1 equals to I1 bracket 10 plus 20, and our V1 will be 30 I1. Meanwhile, our V2 will be equals to our 20 ohms multiplied by I1. Why it's multiplied by 20 multiplied by I1 is because that current I1 is flowing in series to 10 ohms and 20 ohms, meaning the same current that passes through 10 ohms passes through 20 ohms. That's why we have 20 I1 then minus the source, the current control voltage source, that is minus 3 I1, and that will give us 17 I1. And our formula for A, for open circuit voltage ratio, will be V1 over V2, and that will give us our V1 is already 30 I1 divided by 17 I1, and that will give us 1.765, no units. And our C, our open circuit transfer admittance, C equals to I1 over V2. I1 is unknown. I1 divided by our V2 is 30 I1. I1 cancel out, and that will give us 0.0588 Siemens. Similarly, to calculate B and D in the question given to us, we'll place still a voltage source at the input side of the two-port network, and then we'll place a short circuit voltage V2 equals to 0 at the output side of the two-port network. And when we do that, we can then begin to solve for our B and D. But note that for us to calculate our high one, to make things easy for us, we use Nodal analysis to get our high one. Then before then, we assume that at that junction we have a voltage VA at the junction of where we have 20 ohms and 10 ohm meet. assume that we have a voltage called VA, can represent it with anything. So by nodal analysis, by the principle of nodal analysis, our high one will be V1 minus VA over 10, meaning that our high one equals to V1 minus VA over 10. And going further, remember that our high one also will be VA divided by 20, that is the current flowing in the 20 ohm resistor, minus current I2. Minus because the current I2 is flowing into the junction instead of flowing out of the junction, and it is the current I1 that is producing it. So that's why we have our high one equals to VA over 20 minus high 2. So by further simplification, if you simplify it further, you have your V1 minus VA over 10, that's our high one, minus VA over 20, that's the current flowing in the 20 ohm resistor, plus our high 2 equals to 0. Now, you should note that our VA will be equals to 3 high, because our VA minus V2 will be equals to 3I1. And remember that our V2 is already equals to 0. So our VA minus 0 equals to 3I, and our VA is 3I1. Sorry. So, and our V1, it will be 13 high 1. Our V1 will be equals to 13 high 1. V1 will be equals to 13 I1. Remember that is 13 I1 from our. Now, the last parameter of the two-port network, the inverse transmission parameter, represented by small letter t. Note the transmission parameter itself, also called capital letter A, B, C, D parameters, can be represented by capital letter T, and the inverse transmission parameter can be represented by small letter t and also small letter A, B, C, and D. It's the last of the 6 parameter of the two-port network, and its formula is simply V2 equals to A, small letter A, V1 minus B, I1, and high 2 equals to C multiplied by V1 minus D multiplied by high 1. In matrix form, we have our 2 by 1 matrix V2 high 2 equals to small letter A, B, C, D, that is 2 by 2 matrix, multiplied by our V1 minus high 1 I1, that is 2 by 1 matrix, and that will give you the matrix form of small letter t, the inverse transmission parameters, multiplied by your V1 and minus I1. Just like we have said before, that our inverse transmission parameter is represented by small letter A, B, C, and D. Now, going by the formula that I stated earlier on, to get our small letter A, that is to get our open circuit voltage gain, we have to equate our input current I1 to be equals to 0. And for that to happen, when we equate our I1 to be 0, in the first equation, V2 equals to A multiplied by V1 minus B multiplied by I1. You get your A to be V2 over V1, that is output voltage over input voltage, that is current gain, provided that your I1 equals to 0. That is called open circuit voltage gain. The small letter b of the inverse transmission parameter, our small letter b is called negative short circuit transfer impedance. Negative short circuit transfer impedance, and it is equals to minus V2 over I1, that is minus output voltage over input current, provided that your input voltage V1 equals to 0. And our C equals to output current over input voltage, provided that your input current is equals to 0. And that is called open circuit transfer admittance. And our D, called negative short circuit current gain. Negative short circuit current gain, D, is equals to minus I2 over I1, provided that your V1 is equals to 0. Remember that this transmission parameter also we have a mixture of impedance parameter, admittance parameter, current gain, and also the voltage gain. So we have our A and D, that is our voltage gain and the current gain, to be dimensionless. They have no units. While our B, that is short circuit transfer impedance, the negative short circuit impedance, is measured or has the SI unit to be in ohms, and our C, that is our open circuit transfer admittance, is it has Siemens as its unit. So for reciprocal network of the transmission parameter stated that earlier is capital letter A multiplied by D minus capital letter B multiplied by capital letter C equals to 1. Similarly, for the inverse transmission parameter, small letter A multiplied by small letter D minus B multiplied by C equals to 1. The first assignment is that you should listen to the slide 4 of this presentation, after which you should do the assignment and submit the assignment as the number 1 assignment. And the second assignment is that you should calculate for the inverse transmission parameters in the diagram, in the circuit shown in slide 22. There's a circuit was used to solve for transmission parameter in slide 22. So now use the use that same circuit to calculate for the inverse transmission parameters.